Hi everyone. So in this video, we are going to look at question 1 of chapter 5. So question 1 is divided into 3 sub-questions, A, B and C. Let's look at the first question. Question 1A. Copy the graph below. Sketch the graph to show the relationship of pressure against volume according to Boyle's law. So Boyle's law states that at constant temperature, the volume is inversely proportional to pressure. So to show the relationship between pressure and volume, you have to draw a graph that shows that these two are inversely proportional to each other. So we will draw a graph like this to show that it is inversely proportional. Let's look at question 1b. So question 1b, you have to state Charles' law. So we know Charles' law at constant pressure, volume is directly proportional to temperature. But you have to make sure you state it in a full sentence. Okay, so in a complete sentence, for a fixed amount of gas at constant pressure, volume of gas is directly proportional to the absolute temperature. Okay, you have to include the word absolute here lah, because this means that temperature must be in Kelvin. Okay, let's look at question B2. A syringe contains 43.50 cm3 of gas Z at 100.15 degrees Celsius. Determine the volume of gas Z in dm3 that occupy the syringe if the temperature is reduced to negative 21.50 degrees Celsius. Okay, so now in this question, you are not given the pressure. That means pressure is constant. So that's why we have to apply Charles' law. So firstly, you have to list all the information that you are given. So the volume 1 is this one. And then temperature, T1. Okay, just now I said that the temperature must be in Kelvin. So you have to change the temperature to Kelvin. How? We need to plus 273.15. Okay, so you plus this and then you will get the temperature in Kelvin. That is T1. V2 is the one that you want to calculate. And T2 is negative 21.50 degrees Celsius. So you plus it with 273.15. So you will get the temperature in Kelvin. Now, what is left to do is just to substitute all the information in the formula. So this is the formula for Charles' law. So just substitute all the formula and we want to find V2. So here we have found V2 in cm3. But the question asks you to give the answer in dm3. So dm3, we need to change cm3 to dm3. You should know that 1 dm3 equals to 1000 cm3. So to change cm3 to dm3, you have to divide it by 1000. So when you divide it by 1000, you will get this. This is the final answer. Now let's look at question 1c. In question 1c, the volume of 0.5 gram of gas X is 0.8 liter at 0.655 atm and 27 degrees Celsius. Calculate the molar mass and density of gas X. Here you are given the mass, the volume, the pressure, and the temperature. And you need to find molar mass. So the first thing that you need to do is write the ideal gas equation as stated in the tips here, which is PV equals to nRT. Then we need to change the mole here, N, to mass divided by molar mass, since N equals to mass divided by molar mass. So we can write the equation like this. PV equals to M over MR RT. Now rearrange the equation to make MR the subject of this equation. So you will get something like this. Now we need to calculate the molar mass. So just substitute all the values that we have. Make sure the temperature is converted to Kelvin. And the R here is referring to gas constant, which is this value. You can find this value in the list of constant. And when you calculate this, you will get 23.5 gram per mole. Don't forget the unit because you are asked for the molar mass, which has units. This is the first part of the question. And the second part of the question, you are asked to calculate the density. Now, density, you should know that the formula for density is mass divided by volume. So the density of the gas equals to mass of the gas divided by volume of the gas. You are given the mass here and the volume here. Just substitute these values into the equation and you will get the answer. So here is the density of gas X in gram per liter. So that is all for this question. I hope you can understand it. Thank you.